So good day everyone. So here are overview for our topic for today. So we have the different types of logic circuit, the difference between combinational logic circuit and the sequential logic circuit. The third one is the different combinational logic circuit and the application of each circuit under combinational circuit. So first we have the different types of logic circuit. So here we have first our combinational circuit. So for our combinational circuit, so the input is independent circuit, which is does not depend upon the input to generate any output. So that is combinational circuit. So it does not depend on the previous output, but it depend on the present input to generate the output. So the second is the sequential circuit, which is depend on the clock cycle and depend on the present as well as the previous or past input to generate output. So that is sequential circuit. So the difference between combinational circuit, logic circuit, and sequential logic circuit. So we have here, so the difference from combinational to sequential is the output depends only upon present input, while in sequential is the output depends upon the present as well as the past input. Just like what I said earlier, that here in combinational circuit it only depend on present input to generate output, while in sequential it depend on the present output, which is here, and the also it depend on the here the memory element, which is the previous input output of this memory element to generate output. So that's the first difference. So second, do not have any memory element, while the sequential have the memory element. As you can see here, we don't have memory element, while in sequential circuit we have memory element which store some data. So the third one, combinational circuit is faster in speed, while the sequential circuit is slow, because in combinational circuit it it depends only upon the present input. So it applies simultaneously in the circuit. So that's why it is more faster. So in sequential it is slow because it depends on the present input and the previous input to generate output. That's why it's slower than combinational circuit. So here we don't have capability to store, and while sequential is have ability to store. So we don't have combinational, so we don't have capability to store because it does not have a memory element to store the data, while in sequential circuit have a capability to store because of memory element, so it can store previous data. So here last, it is easy to the combinational circuit, it's easy to use and handle, while in sequential it's not easy to use and handle. So it is easy to use because it has no like here it has no memory element that alters the output, while in sequential circuit, the the memory element and the output is dependent on the inputs, the present input here, and the memory element. That's why it's it's not easy to use or to handle. So let's proceed next. So we have the different combinational logic circuits. So we have here the adder, the subtractors, the multiplexers, and the multiplexer. Last one is the encoder and the decoder. So for our adder, we have two types of adder, which is first we have the half adder. So half adder is the basic building blocks of two inputs and two outputs. So the two outputs are the sum and the carry out. So let's have here our truth table. Here we have 0 plus 0, which is 0. 0 plus 1 is 1. 1 plus 0 is 1. So we don't have to carry out. While here, 1 plus 1, 0. So we have to carry 1. So here our logic diagram for our half adder. So the adder is used to perform OR operation of two single bit binary. So here we have the other one, the full adder. So the full adder is also the same as the half adder, but here it add 3 1-bit binary number, which is the A, B, and carry out, and also the output is sum and the carry out. So here are the full adder circuit. So the application is it's mainly used in building blocks of arithmetic and numeric computation, and is used for calculation, used in computers, and performed in ELU, which is the arithmetic logic units, and also used in processor. The second is the subtractor. So subtractors also have two types, which is the half and the full subtractor. So half subtractor have also two inputs and two outputs. So this is used to subtract two single binary numbers of A and B, which is here, and two outputs, which is D or B. Here we can say is a differ and borrow. So we can minus 0 plus 0, 0 minus 0 is 0. We can 0 minus 1, we can't subtract it, so we need to borrow 1. So we have 1 is 1 here, and 1 minus 0 is 1. 1 minus 1 is 0, which is 0 here. So here is the logic circuit of half subtractor. So here is also the same as the full add adder, but it's subtractor. So we have also 3 1-bit number, A, B, and borrow B here, and different borrow. So here are the logic circuit. So next, the application is also the same as the other. It's also most the same as the other. So it's mainly used in building blocks, arithmetic, and numeric computation, used in design calculator, and used in computers, and perform in next is we have here the encoder and the decoder. So sometimes in electronics we need to compress some multiple numbers of input to smaller input. So how encoder works, while decoder is the reverse of encoder, which is it has a lot of multiple input, smaller input, while the output has a multiple number. So application so data compression, so you can compress data communication, like converting data to digital bit, and automatic health monitoring system. So let's proceed to next. So we have the multiplexer and the multiplexer. This multiplexer allows us multiple input signal to produce a single output, while the demultiplexer is the reverse of multiplexer, which has one single output while has a multiple number of output. And also, if we combine these two, we can use it as a switch, right? It helps us to maximize the use of wires. Here we have the application for the communication system. It allows us to transmit different types of data, like videos, audios at the same time, and transmission from computer system of a satellite, computer memory, like, and it implement large amount of memory in our computer, right? That's all. And that's all for today, and thank you.